Again, welcome back. So what we're going to have to talk about is what's notated in our function. And a lot of you are looking at this for the first time. We'll just pause for a second. This, if you read it, it's f of x is equal to a. I know there's a big F. And then there's a bracket, k, bracket x minus d, bracket, bracket, plus c. This is how your textbook writes this. We don't like it here at North Pro. We don't like it. Your handout looks something like this. Now to avoid confusion, because I said to you I will slowly translate or try to go into our textbook, I am not going to teach this way, even though this is in my fiber, this is how we teach it. And technically we use a different letters even at North Toronto. We actually use the letter A, B, C, and D. I don't know why the one in white is there. I actually don't know. And I'll try to explain it. I know there's an F. We'll talk about what F stands for in a moment. But in general, we're going to look at this. So if you have a confusion, I will try to write it here from your textbook point of view. Okay? Now the handouts are there, they're helpful, but I think it'll make sense. In fact, the way that we like teaching this, we actually teach the translations first because they're easier, but we tend to go from left to right. And I'll explain that as we get through. And slow me down if it's finding it difficult. What I'm going to do first, ladies and gentlemen, as I record this lesson, I'm going to talk about what they are, and then we're going to see what they look like. So hopefully it will piece together what's happening. And again, this is actually how animations are used, how you actually hear music, how you transpose things. You change from a different key. So it's a music art or in drama. You take a play or you make it now. You make a satire out of it, so you just translate it. This is what we're talking about. This is the math context. And it's pretty straightforward. The translations we have are called vertical shifts, and I think some of you are still understanding that it's actually the C. So really easy. Plus C or minus C. When you see plus C or the last term that's added there, that means a vertical shift up C units. And conversely, and I'll just close if that's okay, down minus C units. So watch what I'm going to do. Now let me check in, please. Notice what I wrote as an example. I don't know what the function is, but I wrote f at x plus 7. Can someone please tell me, what does this mean to you in terms of transformation? If you don't know what this is, who cares? But this part, what does this mean to you? Omar.
Vertical shift up by 7 units.
Beautifully said. Let's pretend that the original function looks something like this. I'm just doing this as a quick sketch. You don't have to worry about it. Let's just say this is the original function. Seriously, something like that. So that is my f at x. If I wanted to do this fx plus 7, you would take all those critical points and shift it up 7 units. It doesn't have to be perfect, but that's the idea. Shifting up. Analogous as well, if we had a -2, let's just say, it would shift down. But what I'm trying to train you, ladies and gentlemen, is this part. The adding or subtracting. Everyone okay with that? Let's answer now what people are worried about. This F. F stands for function. Function. And if you really think about it, we will eventually perform these transformations onto those 5 base functions. The quadratic, the absolute, the reciprocal, the root function, and I forgot the last one. I can't do it, right? The reciprocal. Anyways, that's not one. Anyways, that's that. Horizontal shifts. Horizontal shifts. Let's get rid of this. A horizontal shift, some of you are going to slowly understand this. It's the x minus d or plus d. So in other words, it's d. And I like using color. I like using color so it makes sense. But notice how I wrote it? Some of you are vaguely, hey, wait a second, Mr. Chen. We did this with vertex forms. That's why vertex form is actually helping us with our graphs. I think some of you actually intuitively know what this means. And I apologize, I'm running out of room. This is a horizontal shift, right, d units, and this one's a horizontal shift, left, oops, d units. Let me give you an example. Let's see if someone's paying attention. F at x plus 3. Different volunteer. Omar can't do this all. Let's see if someone will tell me. What do you see here? Nora, take a chance.
Horizontal stretch left 3 units.
Yeah, whatever the function is. Maybe the function looks something like this. We'll do it up here if that's okay as a sketch. Let's just say the function f at x was this round. I'll say it like this. Maybe it looks like that. That was our function. To perform this f at x plus 3, I think a lot of you know what I'm going to do. You can take all those critical points, maybe this point, and shift it left 3 units. Okay, shift this point. Okay. It's just to the left. Clap your hands. No. Yeah. There's a dance. Forget it. That they play at clubs and weddings and everything. So that's what f at x means. Hopefully everyone's understanding this. Here's where we're getting closer to the hard stuff. Any questions about translations though? Any questions about shifting left and right? That's why I think a lot of you understand that these are kind of like the H's and K's. H's and K's. That's why I don't like this. We don't use H and K here. And there's a reason. Vertical stretch and compression. These are called stretches and compressions. And a lot of you know what I'm doing. So far, a lot of you are connecting. This is obviously related to shape. Notice now I'm no longer using orientation just yet. Orientation's a little, when we were using quadratics, that was really neat. We can't use those anymore. And there's a reason. Because this particular function, this cubic, right, for example, this one we can't say opens up, opens down, right? We can't. There's no open up, open down now for this. Same with the root function. How can you describe this one? You can't describe open up, open down. That is why we introduce and change it just slightly so you guys can familiarize yourself with it. I will slow it down, asking questions. When A is greater than 1, this means it's a vertical stretch by a factor of A. When A is in between 1 and 0, this means it's a vertical compression by a factor of A. Some students find this difficult when I write this, and so I'm going to still use the word, it's directly related. And still some people have difficulty with the English word directly related. So for example, the direct relationship, right? It affects things. If you study hard for your tests, you tend to do well. So it's directly related. Let me give you 2 examples for this. And I'll use a base function for you. So notice, let's just say f at x, and we put a 2 here, and maybe another f at x, half of f at x. But for this one, I will use a parent function that everyone's familiar with. So y equals f at x equals x squared. Maybe we should use a different color. We'll use yellow. No, we shouldn't use yellow. We'll use orange. Just to showcase this. I'm saying the function is a quadratic. So let's just sketch that out. When we see the 2, a lot of you know this means a vertical stretch by a factor of 2. And so it should get narrower. How about half f at x? We take that white function and we vertically compress it, it gets squashed. So that's why I'm trying to show you both of these. A lot of you understand this because vertical stretch compression is what you've seen already. You've seen it. So a lot of you are realizing the A, the D, and the C, it coincides with our A, H, and K that we taught you. But some of you realize, but wait a second, there's another letter. And again, I see there's an F. I think a lot of you understand that the F stands for function. Function. So it's actually not a number. It's actually the rule, or what we're performing. But a lot of you see there's a new letter. And it's K. And K is the hardest one. So at least these 2 kept the same. A and K is the same. And it's called a horizontal stretch and compression. So I'm trying to slow it down. Notice I didn't do any reflections yet. We don't have time for that unless some of you can figure it out. When K is greater than 1, It's not directly related. So in math terms, and I know it's going to seem weird, this is why we teach it now in grade 11. When k is greater than 1, this actually means a horizontal compression by a factor. I'll erase this if that's okay. Of 1 over k. So for example, I know this is hard for some of you, so watch carefully. If we see f at 2x, many students, when they look at this, they think it's this. It's not directly related. The k value, mathematically, it's actually inversely directed. So it's the opposite. Because when you plug in 2 into this expression, what number do we get? Well, I think a lot of you understand when you plug 2 for k here, because k is 2, it represents a half. Now some students ask me, so then why don't they? And that's a very great question. It's just the way that the math works. It is not directly related. Some of you might realize this. In chemistry, when you decrease the pressure of a gas canister, decrease the pressure, oh geez, decrease the pressure, no, hold on. I forgot. Ah, Jesus, I forgot my chemistry. I'll come back to that now. Let's just get this out of the way. And when k is in between 0 and 1, it's a horizontal stretch by a factor of 1. So let me do that example. Please orange. So I'll write this out in English to help everyone out. This one is a horizontal compression by a factor of 1 over 2. So a lot of you understand compressions are fractions, and stretches are numbers that are greater than 1. Even though k is 2 in this example, and k is 0.5 in this one. Hopefully I'm not off speed. Notice I haven't done an example with this one, because this one's a little harder. Okay, let's just pause for a second and answer any questions from anybody from the class. And what you're learning is what those numbers represent and what we're going to do. But I wanted to get them all out of the way, and then hopefully when you look at the handouts that I've given you, you should be okay. Omar, really quickly.
Why would you not say it's a horizontal stretch by factor of 2 instead of horizontal compression by factor of 1 over 2?
For this one?
Yeah, because you said it's the inverse, so why wouldn't you just say that instead?
It did. Horizontal compression by a factor of a half.
Yeah, but why wouldn't you say a horizontal stretch by a factor of 2 instead?
Because it's not going to get wider. So this is a good question, and I know I have not explained this visually just yet. This one's actually hard to do here, but I'm going to do it. Thanks, Omar. And that's why it's weird. Everything else kind of makes sense. And I know this one's weird, right? That's why the horizontal stuff, it's actually weird. It's actually, it seems the opposite. Some of the students are asking, I don't know if it was this class or my other class, when they saw this, why isn't this not shifting left? It looks like it should be left, right? Because it's like negative whatever, like this example. Why isn't this shifting right? This is a +3 here. What are you talking about, Mr. Chen? It's the opposite. Horizontal transformations are weird. And that's what I'm trying to explain here. The stretches are direct, or sorry, the vertical things are direct, the horizontals are kind of opposite or inversely. Anyways, we'll talk about this in a moment. Anyone else? Okay, so I'm going to change up our example in a moment. And how am I doing done? 11:40. Can I erase this? Okay, let's stop recording this.